stunning pictures this morning out of Yellowstone.
In two of the really large eruptions at Yellowstone, so much material comes out.
This restless Yellowstone caldera is truly living, breathing, and every once in a while it burps.
Volcanoes have a unique quality that makes them natural disaster superstars. Magma pushing violently to the surface and erupting with terrible ferocity. Images of the ancient Roman city of Pompeii and its unfortunate inhabitants trapped in volcanic ash and pumice serve as a sobering reminder of what occurs when a volcano wakes up. You might be startled to learn that the United States is one of the most volcanically active areas on the planet. It has 161 active volcanoes in its 50 states and territories over the last 12,000 years. That is, in fact, the most in the world. A massive magma chamber beneath Yellowstone National Park's stunning hot springs and geysers could one day erupt as a supervolcano. According to NASA, supervolcanoes are one of the most dangerous natural dangers to human civilization, far more deadly than asteroids. And recently, a NASA scientist disclosed something terrifying about the Yellowstone supervolcano as well as NASA's plans for it. What is this astonishing revelation, and how does it affect everyone in the world, particularly those in the United States? Join us in today's video as we go through this shocking revelation in detail. What is a supervolcano or supereruption? Both terms are relatively new and preferred by the media over scientists, but geologists have begun to use them in recent years to refer to explosive volcanic eruptions that eject 10,000 times the amount of magma and ash that Mount St. Helens, one of the most explosive eruptions in recent years, ejected. It's difficult to conceive such a gigantic eruption, but the Earth's surface has preserved clear traces of several massive supereruptions. Many continents have been blanketed in thick layers of ash, and massive hollowed-out calderas, craters as large as 60 miles, 100 kilometers across, left when a volcano collapses after emptying its entire magma chamber at once, serve as vivid reminders of previous supereruptions in Indonesia, New Zealand, the United States, and Chile. Massive areas have been devastated by the eruption of these prehistoric supervolcanoes. Mount Toba in Sumatra erupted 74,000 years ago, releasing a massive 700 cubic miles, 2,800 cubic kilometers of lava and leaving a thick coating of ash over the entire region. In comparison, the amount of magma spewed from Indonesia's Mount Krakatoa in 1883, one of the greatest documented eruptions, was approximately 3 cubic miles, 12 cubic kilometers. Volcanologists are still searching for answers to numerous unresolved questions about supervolcanoes. For example, what causes their eruptions, and why do they wait until their magma chambers reach such gigantic sizes before erupting? How does the composition compare to other well-known eruptions? How do we know when the next supervolcano will erupt? But one thing is certain, supereruptions, while they do occur, are extremely rare, and the chances of one occurring in the lifetime of anyone viewing this video are vanishingly small. The most recent supereruption happened some 26,000 years ago in New Zealand. The next to most recent event was the catastrophic eruption of Mount Toba, which took place approximately 50,000 years ago. Geologists have detected the remains of approximately 50 supereruptions, though teams are currently analyzing a variety of alternative possibilities. That may appear to be a high number. However, when one group of scientists calculated the estimated frequency of eruptions by counting all known supervolcanoes, they discovered that only 1.4 supereruptions occur per million years. That is not to claim that a supervolcano will erupt at regular intervals every million years. Several million years may pass without a supereruption, or many supervolcanoes may erupt in a short period of time. The geological record indicates that supervolcanoes occur in clusters, but the clusters are not regular enough to be used to predict future eruptions. However, a recent NASA research shows something unexpected about Yellowstone. Following the publication of an article about supervolcanoes last month, a group of NASA researchers came out to provide a previously undisclosed report about the hazard and what could be done about it. I was a member of NASA's Advisory Council on Planetary Defense, which studied ways for NASA to defend the planet from asteroids and comets. Brian Wilcox of NASA's Jet Propulsion Laboratory, JPL, at the California Institute of Technology explains. During that study, I came to the conclusion that the supervolcano threat is substantially greater than the asteroid or comet threat. There are approximately 20 known supervolcanoes on Earth, with large eruptions happening once per 100,000 years on average. One of the most serious concerns posed by an eruption is famine, with a prolonged volcanic winter potentially preventing civilization from producing enough food to feed its current population. The United Nations calculated in 2012 that global food stocks would last 74 days. When NASA scientists examined the issue, they discovered that the most logical approach could simply to cool a supervolcano. A Yellowstone volcano is essentially a mass heat generator equivalent to 6 industrial power plants. Yellowstone presently releases 60 to 70% of the heat rising from below into the atmosphere through water that seeps into the magma chambers through fissures. The remaining accumulates within the magma, allowing it to dissolve additional volatile gases and surrounding minerals. When this heat reaches a certain point, an explosive eruption is unavoidable. However, if more heat could be retrieved, the supervolcano would never explode. The Yellowstone would no longer be a hazard, according to NASA, if heat transport from its magma chamber could be increased by 35%. The only remaining question is how. One idea is to simply add more water to the supervolcano. However, convincing legislators to support such an undertaking would very certainly be impossible. Building a big aqueduct uphill into a mountainous region would be both costly and difficult, and people don't want their water spent that way, Wilcox says. People are desperate for water all over the world, and so a major infrastructure project where the only way the water is used is to cool down a supervolcano would be very controversial. Instead, NASA has devised a whole other strategy. They believe the most realistic option would be to dig up to 10 kilometers inside the supervolcano and pump high-pressure water down. The circulating water would return at a temperature of roughly 350 degrees Celsius, 622 degrees Fahrenheit, steadily draining heat from the volcano day by day. While such a project would cost roughly $3.46 billion, £2.69 billion, it comes with an intriguing catch that could persuade lawmakers to make the commitment. Wilcox estimates that Yellowstone currently releases roughly 6 GW of heat. Through drilling in this way, it could be used to create a geothermal plant, which generates electric power at extremely competitive prices of around 10 cents a kilowatt hour. You would have to give the geothermal companies incentives to drill somewhere deeper and use hotter water than they usually would, but you would pay back your initial investment and get electricity which can power the surrounding area for a period of potentially tens of thousands of years. And the long-term benefit is that you prevent a future supervolcano eruption that would devastate humanity. However, drilling into a supervolcano is not without risks, particularly triggering the eruption you're attempting to prevent. The most important thing with this is to do no harm, Wilcox says. If you drill into the top of the magma chamber and try to cool it from there, this would be very risky. This could make the cap over the magma chamber more brittle and prone to fracture, and you might trigger the release of harmful volatile gases in the magma at the top of the chamber which would otherwise not be released. Those who initiate such a project, on the other hand, will never see it through to completion, nor will they have any clue whether it will be successful within their lifetime. Cooling Yellowstone in this manner would occur at a pace of 1 meter per year, requiring tens of thousands of years until only cold rock remains. Although Yellowstone's magma chamber would not need to be frozen solid to no longer represent a hazard, there would be no guarantee that the endeavor would be successful for hundreds if not thousands of years. However, in order to avoid a disaster, such long-term thinking and planning may be the only option. With a project like this, you'd start the process, and the main ongoing benefit you'd see in everyday terms is this new supply of electrical power, Wilcox adds. Such a strategy could potentially be implemented to every active supervolcano on the planet, and NASA scientists hope that their designs will spark more practical scientific discussion and debate on how to deal with the threat. Despite these uncertainties, the proposal is worth considering, especially since Yellowstone is only one of around 20 supervolcanoes on the planet. NASA hopes that their idea will spark more realistic talks and debates about what to do about these gigantic structures before an eruption which might plunge the Earth into a volcanic winter. Mount St. Helens was a horrific disaster, but its scale was much smaller. The 1980 eruption of Mount St. Helens was estimated to have produced 0.25 cubic kilometers of material. As a point of perspective, the smallest of Yellowstone's super eruptions was 280 cubic kilometers. How huge an event and how far-reaching an impact would it be if Yellowstone blew up right now? One of the most serious global worries would be what is known as a volcanic winter. In human timescales, we've seen this with much smaller eruptions. It's when there's so much ash in the atmosphere that it shields the Earth from sunlight, and you can get a degree or two of cooling, which may not sound like much, but it can have disastrous consequences when it comes to agriculture. As a result, the effects of the volcano would almost likely be devastating. A massive eruption like this would have regional percussions like falling ash and short-term, years to decades, worldwide climate changes. Sections of the surrounding states of Montana, Idaho, and Wyoming would be affected by pyroclastic flows, while other parts of the United States would be affected by falling ash. The amount of ash would decrease with distance from the eruption site. Those who are in or around the park will most likely have no idea what happened because a massive explosion will occur at the start of the eruption. Those further away will not be affected by the explosion, but the picture may not be much better. Let us know what you think of NASA and its study on Yellowstone's supervolcano in the comments section.